is basically a Yagi antenna. Next week we'll cover antennas, different sizes, shapes, and so on. But we're covering the Yagi today because in the past, for the Boy Scout Jamboree, we have made some 440 Yagi antennas. After this class, we'll be making some 2-meter Yagi antennas and so on. And that's when we see making their kits that we have made, and they use a tape measure for the antenna. So we're not going to go over basically that part of it. We're going to go over why a Yagi and why would we want to use it. So first of all, Yagi, I think was a Japanese radio man, probably maybe a mathematician. I don't really know his background, but anyway, he's very famous in the radio world for his style of antenna, which is we're going to cover. It's very, very clever. So anyway, underneath the drawing there, just draw a line about as long as the one you got up at the top. Okay. Now down underneath, draw 2 lines, not touching but perpendicular. No, 2. Not touching. There, draw a line down. Okay, we've covered pretty much before a little bit of radio propagation and radio waves and so on. So basically there's 2 types of antennas that we're going to deal with more or less. There's a few more, but the 2 basic ones are vertical and horizontal. So the vertical ones there, you can see, are generally speaking monopoles, they're called. However, generally speaking, for a radio wave, the way radios pick them up, you need 2 parts of it. So on the one on top, in the middle of just make a little X. Okay, that now has become 2. That now has become what you call a dipole. So it's a vertical and a horizontal. So the verticals, generally speaking, sends out the propagation wave all around them in a circle. So draw a circle underneath one of them. Okay. So now what you call a propagation wave is you go from the center of the circle and where the radio wave goes. So make a bigger circle around it. Okay. So if you look down on that monopole from the top, that's what you see. The radio wave goes all over. That's a waste of electricity. It's a waste of energy, a waste of money. So the bottom line, if all you wanted to do is go to the next guy over there, then if you think in terms of how lenses work and the visual spectrum, you just take a mirror and push it over. You take the light and push it over. None of this you'll see. So if you take a flashlight, it only goes that way. It doesn't go back. So what we're going to do is direct the beam. We're not going to waste all of it going all over. We don't want it going east, west, and south. We only want it going north. Okay? So we're going to do what we call increase the efficiency. Okay? So now you have to decide how you want your antenna set up. Do you want to set up vertical, or you want to set up horizontal, or in a circle? And if it's in a circle, the way a lot of satellites are, does that circle go around right-handed or go around left-handed? So you can have polarity that is circular, that is right or left. So we're not going to go into that today with the Yagi. So on the Yagi antenna, as I said, it's a dipole. You can see your contact point coming up to the middle. Now this is very important. You've got voltage that you're going to talk about in RF, and you've got resistance. Elisa, how do we do resistance? Come here. Resistance. Everything resists. Everything resists. That's the law of nature, except in space. But in our atmosphere, there will be resistance. So what we're doing is looking for the best conductors in the world, and that, generally speaking, is copper. We've settled on copper. It's good, it's cheap, and available. So basically, if you got in your mind now, you've got to think about two things: the power that's going out, the energy, and what's holding it back. The air holds it back. Metal holds it back. They all have their own percentage of amount that they hold it back. Conductor will be probably 99% conductance, 1% resistance. Okay? So that's the first thing you have to get through your head, is the resistance of the radio wave. Now, this is where you have to start understanding waves, and we talked about waves almost what I call ad nauseum in the past. The waves can be the length of a football field, or they can be 2.4 megahertz in 1 second, or 5.8 in 1 second megahertz. They're awful short, okay? Or they can be very long. So what we're talking about today is what you need to know to get your technician radio license: a 440 band and a 2 meter. Those are the two that are short, and they will let you play with. The reason being is that the higher bands might go around the world, which we'll talk to under propagation. So they don't want a beginner sending a signal from here to Germany or from here to somewhere. Okay, it's okay to send it from here to Copper's Cove to a tower, but that's it. So that's the 2 meter band and the 440. Well, the way I explain it, at least in my mind, it makes sense. If you want to learn this, you can go out to the pond somewhere or still water, and you drop a stone in it. You'll see the circles going out. It's going to go out, get bigger and bigger. That's what that radio wave does. It sends out that radio beam. The problem is, it's got resistance. The water is going to hold it back. It's going to hold it back. So now you have resistance on it. Then the key thing is, it's going to hit the shore. When it hits the shore, it's going to come bouncing back. This is very important. And until it runs out of energy. That's what you've got to know. That bounce back there is right down standing wave ratio, SWR. Or you can put VSWR. That means the voltage. Okay. Now, at the top of the dipole there, put up there, 0, no, the dipole up there. There, yeah. 0 ohms, omega. You know what the omega is?
Yeah.
Greek letter? Good, okay. Ohms. That's 0, okay. Well, you want it as close to 0 as possible as a general rule, but you're probably not going to get 0. So they have decided what they're going to use mostly, and it's feasible, is 50 ohms. So what we're going to know, don't write that down, but just write it up top somewhere there, 50 ohms. Just think about it. If you're in the radio and anybody asks you questions, if you say 50 ohms, you're probably going to be right. It's that simple. You're always looking for 50 ohms of resistance. Now, when you get to TV, that might go up to 75 ohms. So you might buy a cable that's 50 or 75, but for beginners where we're at, 50 ohms is what we need to think, okay? Which means you now need to measure that. So that's what they call the standing wave ratio. So what it is the ratio, the voltage plus the resistance. It's the ratio on the bottom, the divider, the ratio, or the voltage minus the resistance is the ratio. And you want that ratio, therefore it's 1 to 0 or 1 to 1, okay? So you want it 1 to 1. So write that down under standing wave ratio. 1, 2, when I say 1, you put 2 little dots in mathematics.
Huh?
1 dot dot.
Like a
colon.
ratio.
Oh, a ratio.
Yeah, 1 to 1.
Okay. Oh my.
One, just
I almost
one.
put a 1. I'm in a 2.
This is good. We're going to learn a lot of math, a lot of physics.
Yeah.
There you go.
So one of them is where we're at the dipole. The other one is where we're at down the line at 50 hertz. That's that thing way out here hitting the sand, and then it comes back. What we want to know is that amount that comes back. We want to measure that, and we want to get it back to the sand. Okay? We want that ratio to be 1 to 1. Okay, so let me give you some ratios to work with. 1 to 1 is good. 1 to 2 is okay. Write that down.
1 to 1 is good.
1 to 1 is good. 1 to 2 is
1
okay.
dot dot 1 is good. 1 dot dot 2 is okay. 1 dot dot 3 is not okay. You want to write that? Got it?
Yeah.
What that means is, this is where I'm teaching you all to be safe. The key word in electronics, electricity, is learn it so you can do it safely, handle it. People are killed by electricity all the time. They're killed by lightning. A lot of times for no good reasons. Okay? So, you've got to learn some basic principles, and that's why we teach physics in high school. So, and we want that ratio to be 1 to 1. 1 to 2, if we can't get any lower, that's probably okay. If it's 1 to 3, don't transmit. What that means is that electricity, that ripples coming back into the middle, and that's electricity going into your electrical device. And the output electricity may be stronger than your electrical device can handle, so it could blow up, just like short out. So you don't want that to happen. Plus it could harm you. It's going to get hot, it's going to burn up, and you might burn your hand or burn your house down. Who knows? That's why this becomes relatively important. Okay. Now, therefore, put a wavelength down, a 2 meter one. Go ahead. A wavelength,
Like a sine.
a sine wave, yeah. Okay, and draw in your parameters. Good. Good girl. She's got it. This is important. You've got to know these. The amplitude, okay? That's one sine wave. So what we're going to talk about today basically is a 2 meter Yagi antenna. A 2 meter sine wave. A 2 meter radio wave, which is what you get your license for when you pass your technician test. 2 meters. Okay? So now, if you look at the sine wave, you've got upper part of it, and you've got the lower, plus or minus, however you want to think of your mind. And if you're talking 2 meters, right down the middle, so make that 2 meters long, The whole thing 2 meters. Now, what we want is an antenna that is 1/2 meter, 1/4 meter, or 5/8 meters. Okay, so write down 1/2, you can see. So if that's 2 meters long, a good antenna, probably the best antenna, is 1 meter long, 1/2. 1/4 would be 1/2 of that. 5/8, you can figure it out. But anyway, this is why you need to think about the length in tuning the antenna. So what we're going to talk about now is how to tune that antenna. Some antennas come with a little tiny, if you know in the old days, the rabbit ears on top of your TV set, you pull it out and you're tuning the antenna. Most people don't know that, but they're tuning the antenna. Pull this one out, pull that one out, till the picture looks good, you just tune the antenna. Okay? Some antennas will come with a little thing on the top, you pull it out to tune it, to get the right length. So we'll talk about later on in a couple weeks on devices to tune these antennas. Once you get it made, you're going to have to learn how to tune it. So, okay, let's go up there. This is our tuning device up there is a capacitor. We've gone over, flip the page. The components you have to learn, okay? The two important one is a resistor, and that's a thing like that, so write that down. Resistor. Ohm's law, when we learned it, you use a resistor for every circuit you have. So if you have 100 circuits, you'll probably have 100 resistors. Resistor makes Ohm's law work. The next is a capacitor.
I got it.
Extra
That there's a capacitor.
capacitor.
And a capacitor,
Yeah, I'm not sure.
generally speaking, is two plates.
You spelled it right.
Yeah, but
Okay.
I don't know.
Oh, how do you make it?
Two plates connected electronically with air between them, and then a plate there. And that plate can cover it, half of it, or all of it, or none of it. Well, she's got a picture of it.
Yeah, but I didn't know which part. You just gave me this paper.
So that's the electronic symbol for capacitor. So we've gone over when we talked about making our heart machine, simulation machine, high band filters and low band filters. What you do is use a high band of capacitor and a resistor to make these filters, which we've already gone over pretty well in the past. So for this case, we're going to use a capacitor. And a capacitor is basically, you put a sheet of metal between there, or a sheet of something, and you pull it up, and now you've got half of it covered. Pull it away, and it's all covered. So this is the way you're going to tune this antenna. You're going to cut down that resistance, capacitor is, by going them down. Now if you have a real tuner, you're going to have plates like this, and you turn them like so. There's air between them, and you're going to change electricity coming in here to electricity coming out there. Therefore, you're going to change the resistance. Resistance almost always has to have electricity, or there's nothing to resist, right? So there's no electricity. There's resistance here, but until I put a electricity in here and a negative on the other side, we don't have a circuit.
Right.
So when we say resistance, we've got to think there has to be a circuit going. So, okay. So now, take those apart. Give her this one. Now these are, pick up that one. Yagi antennas that you buy, okay? So if you look there, it's pretty much like the drawing, okay? Got it? Okay, this is one that's foldable, it's a little bit safer for a young lady like this to get out of the car and take around and so on, so. So this is spring loaded. A little hard to work, but anyway, it does work.
It doesn't open. They don't open all the way.
Well, I'll get somebody to do it. It does work. I use it.
They only open like this small.
So anyway, now, draw that, Salisa. Like so. You got it? Okay, now draw this here on the middle.
This is it.
Just something there, doesn't matter. Okay? Now, this is a Yagi antenna. A Yagi antenna. This is your driven element. Okay, now draw a wire coming in there, 2 wires. That's going to get the RF signal. Okay? This is a driven element. The length is very important, so put down here just a line so you've got a length.
Do what?
Yeah. In drawing, if you just put a line here and a line here, and a line with a hole in it.
Oh, okay, I know what you're saying.
Okay? Notice these are different lengths here. This is longest, shortest, middle. This is your driven element. So if we want this to be a 2 meter, this one ideally would be, now when I say 2 meter, if we're gonna half wave or quarter wave. So let's say we're gonna go half wave, that would be 1 m long, 1 meter. Okay, the driven element. So write that down, driven. Now this is where, again, I use visual. This is like a mirror, okay? Your radio wave is coming in here, look there, just 1, 2 meters long. An arrow, and then 2 meters, 2 m. 2 meters coming in, okay? So what you want to do is read that down here. So this guy here is the dipole, the one that's going to use it. This guy here is just a tag along, but he helps out. It's like a mirror. He's going to take some of this signal and push it back there. Same thing.